Great. Thank you very much, John. And thank you very much for inviting us to have a chat today about AI in sports. So as a quick way of introduction, my name is John Flynn. I lead our data and AI practice for our Microsoft Sports business. And that includes our leagues, the clubs and teams that fall underneath those leagues, and venues and ancillary businesses. I'm incredibly excited and honored today to be joined by Jake Switzer, who is arguably the brains behind the operation of everything that we do from a data and AI perspective on the Microsoft Sports team, and Param Singh, who is our AI and machine learning guru. He's just so smart, it makes my head hurt most of the time. But I'm going to throw it over to Jake and then Param to give a quick introduction on themselves, and then I'm going to start peppering everyone with some questions. And everyone online, if you want to drop any questions in the chat, do so. We'll get to as many of those as we can in real time through the presentation. Jake, over to you, mate.
Awesome. Thanks, John. So hey, everybody. Thanks for joining today. My name is Jake Switzer. I'm a cloud solution architect based out of New York. My focus area, or where I help our sports leagues and teams, is around our data platform, advanced analytics stack, how they can use technology or use data services on both the business operations side, so think ticketing, fan engagement, that sort of stuff, and then also on the fun sports performance side, so Moneyball, biomechanics, that sort of stuff.
Awesome. Thanks, Jake. All right, Param.
Param Singh. So like Jake, I'm part of Microsoft Customer Success. I work in a team that's called the AI Rangers. So we focus on working with customers to develop things like proof of concepts, minimal viable products, enablement questions, advice, strategy, so on and so forth. We also work with some product teams to help kind of influence the vision and kind of direction of some of the services that we offer. I enjoy working with Jake and John. We've worked in sports for a little bit now, and we've done some interesting work, and I'm happy to be here. Thank you.
Awesome. Thanks. And I see we also have Tom joined us here as Jean's guest as well. Tom, do you want to just give yourself a quick introduction? Or not, maybe it's something you said. All right, I'm going to start real easy. I'm going to throw this one, Param, to you real quick. Sports is a very nebula term, right? I mean, it encompasses multiple disciplines. It encompasses multiple facets of the business side. There's a product on the field called Diamond side of it. Artificial intelligence is equally nebulous term as well. It means a lot of different things to a lot of different people. So I'm going to give you the invariably easy task of saying, what is AI in sports?
Sure. This is just my opinion, right? So when folks say AI, to me, that means I'm trying to replicate some sort of human function. And you see that in things where your car now has vision, right, and can detect people in front of you and that sort of thing. And in that vein, when I hear AI in sports, I think it's what I kind of call like the next generation of what we're starting to see in the industry, where it's not replacement, but enhancement of things people normally do, right? And you see that a lot in things like decision making. The other part of it is, there's this AI moniker for things, right? The tent pole, as it were. And it's really what they're talking about is advanced statistical means or machine learning, right? So that's kind of the bits that drive what I talked about earlier, where it's the decision making. So that's just my 2 cents.
Awesome. Jake, you care to elaborate on that?
Yeah, I think Prime hit the nail on the head in regards to AI being really, it's a way to augment human decision making, right? So whether it's a coach on the field who throughout practice and preparation, using statistics, using artificial intelligence models to make predictions on what personnel lineups they should use in certain scenarios, and then taking that to the game, saying, all right, well, I know that this is what all of the practice, all of the AI models, all of the analytics that I use. This is what it said, but this is the scenario. Maybe it's raining, a player goes out, is injured. So having all of that information along with the experience, I think that just enhances the quality of the game. And then on the business side, it's all about how do I, as a sports franchise, make the experience for the fan more personal, more engaged, so that we have more fan buy-in. Younger fans are wanting to come to an event. That I think in baseball, the average age of a fan is well into their 50s, and so it's using that sort of information and those sorts of models to really drive home, hey, how do I appeal to the younger audience, to the millennial, to the Gen Z audience, and bring them into the stadium? Or, if they're going to sit at home, how do I reach out to them and connect with them on that personal level?
Yeah, I think that's totally on point. One thing that I figured out real early when I first started working in sports from a technology and sports technology perspective is that talking about any technology, and particularly artificial intelligence technology within sports, there's really two sides to it, right? There's the business side to it, and then there's the game side of it, right? The player side of it. And there is so much work being done on the business side of it to present sports to a wider audience, to present it to a different audience, or even present it in a different way that new audiences will attach to it, right? And I think that the leaps and bounds that we've made from just a fan experience perspective have been incredible, right? I mean, if we look at some of the stuff that Microsoft's doing, but also what partners are doing that we partner with, and then outside of Microsoft as well, just the breadth of options that people have for watching sport. And now they're no longer being passive audiences. They're being involved in the game that's on the field, on the diamond, on the court. It's absolutely amazing. So, Jake, in our experience, I mean, we do this on a daily basis, right? But in actual running of a club or a team, how much do you think the business relies on artificial intelligence to help them run it more efficiently?
Well, I think it goes back to taking human experience and then augmenting that with data, and that's what artificial intelligence is really allowing a lot of the different franchises that we work with, allowing them to do. So I spoke earlier about fan engagement, how to create a more personalized experience, how to bring fans back to the stadium. We all know that the last 19 months has been hectic for everybody in sports. Last year, most sports leagues, we'll say most, did not allow fans into stadiums. Now some started to open up gradually, but now that we're back full tilt, how do we reach back out to those fans and say, hey, we want a full capacity stadium, or convincing them that this is the way to go? Because a lot of people have gotten very comfortable in their houses, watching the games, right there on their couch. Beer is colder, food is fresher. How do they make that experience more personalized? So the way that I think of it is almost like a cognitive stadium, where the stadium itself is almost like an extension of a fan's home. How do we, or how does a franchise better relate information or relay information to a fan on where are their large lines for concessions, for restrooms, that sort of stuff, and where there are no lines. So just allowing the fan to know that, hey, the stadium is here working for you. We want to make it as personal and as home-like as possible. I think that's where AI is going to come into effect, where we're seeing it today, and where it's going to become more and more important down the road. So all about fan engagement and all about getting fans back into venues. And on top of that, it's also a great way to reach out to fans all around the world. There are sports like the NBA that are very global. There may not be a favorite team per se from somebody, let's say in Greece, but they may have have an interest in the Milwaukee Bucks, not necessarily because of Milwaukee, but because of Giannis, right? So it's all about reaching out to those fans in different different locations, all about making very global, large distances very short, very quickly, and treating it like a personalized experience.
I think that's a great call out. That one-to-one relationship is something that all teams and leagues are working towards and striving towards, right? Because if you think about the old adage of spray and pray with an email, if you signed up for a Bucks mailing list, that doesn't play anymore because you don't know John the Bucks fan or Jake the Bucks fan, right? Or not necessarily a Bucks fan, you don't know who I am in Athens as a Giannis fan, right? That's changing because people are expected to have the team talk to them because the product that they put out is so much better. Now, Param, I know you do a lot of work with us around the game side of things as far as artificial intelligence is concerned. How much of an impact do you see artificial intelligence having today on the actual game itself that's being put onto the court, the diamond, the field?
Yeah, a lot. And I think that's happened as a result of a lot of data being available, right? And that's not anything new, right? It's pretty public. It's out there. Everyone knows there's all this tracking data. The NFL is very, for an example, right? Tracking it for very clear medical reasons, right? So you're seeing kind of these silos, well, not silos, but these tranches being created as a result of the kind of this explosion of data. And then this need to help understand what's going on in terms of like a descriptive stats perspective, and then help kind of model things or behaviors for the future. Something that's very big right now where it's kind of influencing the game directly is things like injury prevention, right? That's becoming very, very huge, where you'll track things like telemetry during practice, during games and that sort of thing. And then that helps you make informed decisions about physiotherapy choices, altering practice styles and that sort of thing. You're seeing that. You're seeing things like automated play calling, right, where the coaches have illicit decisions based on, a Bayesian or probabilistic deterministic view of, hey, this is what happened in the past, and this is very likely an outcome that you can model in the future as an additional point to consider with other things. So there's a slew of that stuff happening, and it's really due to this kind of explosion of data that's occurred, right, in I think every major sports league. So.
Yeah, I think one of the things that we see and one of the themes that we keep hearing, or one of the buzzwords, right, is data, right? So one of the things that we see on a daily basis is terms like modernization, terms like integration, right? And it all has to do with data. So in order to get to a state where you can apply statistical modeling or you can apply artificial intelligence on data, the data itself needs to be worthwhile, right? It needs to be worth something. So, Jake, where do you think the state of data is now compared to where it was? Because take baseball for your example earlier, right? The average age of the fan is 50. They've been keeping scorecards ever since there was sort of tablets and the chisel to chip them out on, right? Compared to where it's come from now, where do you feel that the state of data is today, and how does that help the teams from an artificial intelligence lens?
Yeah. Well, just like any other industry, there's a lot more of it, right? There's a lot more ways to capture data, to ingest it, whether it's still just batch processed like what we've been doing for years now, or real time. Things are coming in very quickly. You have IoT sensors that are attached to an athlete, cameras that are constantly tracking different movements and different events during the course of a game or a practice. It's all over the place. And so traditional data storage and data processing methods just don't add up as far as providing value out of all of these different data sources. And so, we're Microsoft people. So talking about traditional data stores like SQL Server, they can only get you so much, right? You can only scale up so much vertically. At some point, you're going to reach the limits of CPU memory on a single box. And so this is where distributed computing paradigms or platforms such as Spark can really help to process all of this data out, whether it's in batch or in real time. And so, maybe 6-7 years ago, distributed computing platforms very difficult to stand up in an on-premise environment, and that's where the advent of cloud computing with distributed compute match it together. Very easy to get stood up very quickly and to start grabbing value out of all those data sources. The kind of how cheap it is now to store data in file storage in the cloud, such as a data lake. You can grab all the data that you want from all of these different sources, organize it however they however it makes sense to them, and then just start playing around with it. So I think today instead of it taking 2 weeks to process loads and loads of data, you can now process it just like that, right? So you have the option of saying, hey, I have millions and millions and millions of rows of data from a single game, and I want to add that to all of these other games. And this is grabbing a lot of tracking data, tracking events throughout the field. Let me actually take advantage of all this data that's here and create some new insights out of it. And I think what we're seeing today with the advent of newer technologies and newer data sources is new ways to think of how to play the game, regardless of what game it is, how to prevent injury, how to keep fans in stadiums. It's I think today more than any other time, it's a very exciting time to be in sports and in sports analytics, because we're able to iterate these different models, these different technology solutions very quickly, and just try new things, try fun stuff.
That's awesome, right? And I think you're right that ability to try new things has never been easier. That's for sure, right? And people are more keen to try things that are a little bit different, because the cost of failure isn't so high anymore, right? Either from a technology or a time perspective. So that's played into it. But Param, as someone who helps us on a daily basis with actually making sense and producing an output from the technology that you build, is more data better for you, and how does that look? Because there's so many sources and data keeps refreshing itself and it ages out even quicker. At what point do you go, oh great, this is enough, or this is good data, I can actually do something and produce something wonderful? What does that look like?
Yeah, so more data is better. Generally speaking, you'll never have a data scientist tell you that less data works for this. I think what's important, and you see this across the leagues as well, right? Like every kind of major sport that's doing what Jake was referring to, right? With this big data, with this, all the spatial, and it's measured sub-second, right? And with those camera arrays and that sort of thing, it's huge, right? It's big. But a lot of credit to the leagues, because that data is generally accurate. And where they don't have things like, readings, they're able to provide you with, here's where we feel the capture was confident during, these kind of time intervals, and here's where it's not. So you're very able, as a practitioner, you're able to kind of quickly filter and use all of those. And you have access to just like, it's an absolutely rich, kind of very granular level of data that you would normally not be able to kind of process unless you were doing it yourself. And the cost of doing something like that yourself, prohibitively expensive, right? You're talking about probably like the top 5 teams in every sport, right? That's how much it would be to kind of really kind of roll that on your own. And, along with that, you have not just the amount, it's the quality. So there's pre-aggregations available with a lot of these data sets. And you're starting to see value from not only looking at that, but teams are using just the raw telemetry themselves, right, to help with some of these more advanced analytics and machine learning scenarios.
Awesome. And now I think, Tom, you're with us now, hopefully on a more permanent basis. I know you were popping in and out earlier. We were worried maybe it was something we said. Do you want to just give yourself a quick introduction there, mate?
Oh, yeah, guys, I've never been more offended by the things you've been saying today. No, it's an honor to be here. And I don't normally play in the sports domain, but I'm a big proponent of please don't ask the data scientists to be domain experts, but demand that they know how to talk to domain experts and stakeholders. So I was quite overjoyed that Gene invited me to be part of you guys. I wanted to qualify a couple of things you guys have been saying. I only like more data when it's good. You keep throwing more dirty data at me, I'm just going to get mad. Or, at least if I know how to clean it. But also, I strongly agree with it is getting easier. I remember when I was first learning neural networks, I was coding them from scratch in C and doing memory allocation. Thank God those days are over. NumPy, SciPy, TensorFlow, it's all plenty fast now and very easy to use. But the only thing I'd like to add to the discussion briefly is those getting started in any domain, especially this one, don't feel like you got to dive into the more complicated models. Build up your own tool set and borrow it as much as you can from others that are successful. But start with the simple models because they give more insight. And typically, the more complicated the model, the harder it is to interpret. So if you have a spectrum of models, you can gain more insight. That's really the only thing I wanted to add to this already rich discussion.
That's awesome. Thank you, Tom. And it actually plays very well into something that we hear, excuse me, from our clients and prospective clients on a daily basis, right? They don't come to us and say, hey, we want some AI. Okay, that doesn't mean anything, right? They'll come in and say to us, hey, we've started doing these and we've built these models in our studio or flavor du jour, right? And we've seen this lift and we think there's value there. Can you help us get better at that? What else can we do? Because I think being able to start isn't the problem anymore, right? There's sort of AI as a service is out there. To your point, Tom, reuse models, reuse stuff that's out there that you can. And that first lift that you see is massive, right? Going from zero to a result is the biggest leap that you'll get. And now it's refining that and to make it sense for my business outcome. And I think that's one of the things that we learned real quickly is that doing AI for the sake of AI isn't cool, isn't going to get you anywhere, right? You have to attach it to something that is real and relevant for the business. And a lot of what we've been seeing on both sides of the house, and I keep referring to both sides of the house because it's very, very different outcomes that the teams are looking for or even the leagues are looking for. If it hasn't anything to do with the fan, it typically has to do with how do I run the business more efficiently. If it doesn't have anything to do with the business, is how do I keep my players on the field for a longer period of time? How do I keep them playing better? So I think one of the things, and it gets a little bit controversial depending on who you're talking to, right? But Jake, you've had a lot of conversations around this, right? That line gets blurred between AI inference of a next best action and a professional coach saying this is the next best action. How do those two worlds prevent collision from a coaching and an AI perspective, and how do they work in harmony for the players on the field's benefit?
Yeah, I think, at the end of the day, if we're talking about sports performance, at the end of the day, players are still going to win games, right? So a really good quote from Buddy Ryan that I'm going to paraphrase here is that all coaches need players. Some coaches can win with them. Some coaches can't. But no coach can win without good players. So at the end of the day, being able to develop or to bring in personnel that makes sense for the offensive or defensive philosophies that certain coaches are going to use is going to wind up winning more games than not. Now, AI models, machine learning, analytics, to me, they make the most sense they come in the most handy during the preparation. So the weeks leading up to a game or the even just the week before a game, right, is that sort of preparation, gathering data on the opposing team, gathering data on your own team, figuring out what sort of personnel alignments make sense for different decisions, as well as, on the medical side, understanding how much longer can a certain player play with an injury, or how far should we push a certain player. Gathering those type of tidbits, it gives certain advantages for actual game time decisions. Now, game time decisions are always, to me, going to come down to a mix of preparation, so all of that AI and analytics, and then coach experience. So being able to decide in a certain situation, all right, the models that we've been using for the last couple of weeks have said this, but we have a sudden rainstorm, or a certain player just got injured, something that just happens, and experience trumps anything else in those cases. Now, I think when we start to favor one side over the other, then you can run into some issues. Definitely, obviously, all of us are technologists, or could be statisticians. We're all over the place on the call. So we think traditionally of coaches that say, "Oh no, analytics, AI, that's not for me," and most of the time they're either going to wind up not changing with the game, or they're lying. Bill Belichick talks all the time about how analytics is nonsense, but he's probably one of the smartest coaches, if not the smartest coach in football history, and uses numbers all the time to justify his personnel decisions. Now, on the other side of the fence, there are scenarios where AI, analytics, machine learning can be used too much and to a detriment. In a way where maybe a coach or a manager, they're not actually making the decisions. They're not making any sort of, they're not using their experience to change things on the fly, to adapt very quickly. They're just using the game plan that was set by their analytics team, and that can run into issues because we're all human, right? As are athletes who are on the field, and so things happen. Things happen that are out of our control, and so experience is very important to making things go on the fly. And so that's kind of what I think of as far as finding that fine line between experience and AI models, machine learning, to really go into a game.
I think it's fascinating just how interesting the game of sports data and applying that all together actually is, because you always have the human element in sports, right? And the human element is probably one of the most unpredictable elements out there, right? You could feel poorly, you could be in a bad mood, you could be in a bad mental state per minute, per play, right? Based upon what a reaction and what a result is, right? I mean, you're, as an athlete and a coach, you're conditioned and trained, you're a professional in a certain area, but your area is built on quicksand because it changes at any given moment, right? So with that, Param, do you think, no, you can be totally honest, be and be as personal as you want here, do you think that AI in sports makes more impact on the field or off the field?
Personally, off the field. And a lot of that has to do with stuff that you're just talking about, right? You and Jake, right? The stochastic nature of it, right? So you're always going to have unpredictability, and any given Sunday, right? And all of that. And I think we were chatting last week about, like, look at the U.S. women's soccer team that won. I forget what World Cup it was. Stacked, supposed to be the best in the world, missed every penalty kick and came in second place. Things can just get in your head, and game time it's harder to make decisions and model those in a way that's usable in a real time, right? What's more valuable is looking at them either after action report, right, or in preparation, like Jake was talking about, right? This is what we did. This is what they did. Here's how things reacted. And then some games have more natural stoppages than others, right? So like in a game like American football, right, you have more opportunity to do some of that more in-game type things. And you can see that with stuff that's just out in the industry, right? Like there's high school football teams right now that are using automated play calling software you can just go buy, right? Which is kind of nuts. But I had to see it to believe it exists. But then you have sports like, soccer or football, right, where there's no stoppage, right? You play until someone gets injured or there's a halftime, right, or the end of the game. In situations like that, there's no opportunity for it, right? As much I would like to see Klopp yelling at people on the sidelines. I don't know how much that's effective at getting people, like get Mo Salah to run back, or the Ted Lasso park the bus, right, and all that stuff that happens. Like, so some sports are more akin to having that sort of stuff happen in game, right, where there are those stoppages and you have the opportunity to leverage that, and there are kind of real-time telemetrics coming in, or probably a better use for them, right, or stuff that I see that gets used more is either after action or in the prep. There's just so much more you can do with that, and it's better to focus energies that way.
Awesome. Tom, I'll throw that over to you for your 2 cents and your personal view on that, because I can tell you we ask that question quite a lot of ourselves when we're working with these various teams and various leagues, and the answer is very different. Sometimes, to Param's point, it is very sport dependent as well, right? Because if you have something that is completely nonstop and there is forbidden rules for you to have offside to on-field communications, intra-game AI doesn't make that much of a difference, right? But what are your thoughts on that, Tom? Just your personal opinion, mate.
Well, based on my expert research in this area, which is completely based on watching the movie Moneyball, I completely agreed with y'all saying it makes a bigger difference off the field. And it kind of makes sense, because what can AI do real time unless we're going to equip the players with glasses or something? Of course, you could inform the coaches better through stuff real time. But I would think that improving the system, meaning who you've recruited, order of play, all sorts of other things, statistics on plays and those types of sports, I can imagine all of that is offline learning. Now you can take it to the game. It has a result during the game. But yeah, everything y'all are saying makes very good sense to me, even though I've not applied my skills to the sports domain. But I really found the movie Moneyball compelling. And an interesting note for those that didn't know, Jonas's character was actually 2 people that were being used. It wasn't just one. There were 2 analysts working together. So it was a little more dramatic just having Jonas play it.
A little bit, yeah. I think that was the budget cuts that they have. They had to roll it into one one actor. Well, Jonas's his paycheck was too big. They couldn't afford another actor to be there. But it's a good point, right? I mean, and that is something that gets obviously romanticized about, because it is a great story. And looking outside in as to what they were trying to achieve, they were trying to just build probability in their favor, right? They weren't trying to get efficiencies on who was running from first base to second, but they were just trying to put the right batsman in front of the right pitcher and the right pitcher on the other side of the batsman, and the person who has caught the ball the most, put them in the place where they catch it the most, right? Let's just do this. And they got pretty far, right? And I think that went a long way in my personal opinion, in accelerating the adoption of that type of technology in sports, right? As much as, and look, maybe it's art imitating life or life imitating art. I don't know who we're taking the lead from here, but I think we see it today. I think, what are we, sort of Moneyball 4.0 at this point, right? But those premises still remain, right? I mean, it's a solid foundation, and that's what we apply. We also have this debate about, does technology make better players, right? And I often go to the example, okay, well, look at the top 5 all-time home run hitters in MLB's history. Out of the top 5, there's only one active player today, right? Out of the top 3, we have Barry Bonds, who has an asterisk next to his name, right? And then we have Hank Aaron and Babe Ruth. And I think as far as Babe Ruth is concerned, no one's going to say that he had the world's top conditioning coach, and he had the world's best dietitian. I mean, he was like, I want steak and a bourbon, and then I'm going to go hit a home run, right? So if we are making better players through technology today, how come we're not seeing that in something as silly as a home run list on who it is? I think out of the top top 50, there's only like 5 or 6 active players today. So are we making better pitchers? Is that the question, right? So Param, do you see the work that we do with the teams on the player side of the house making better players at the end of the day?
Yes. And a lot of that has to do with what we were all talking about, right? So there's just this explosion of data. And if you look at just improving a pitcher, right? In practice and during games, right, those performances can be measured, especially in a sport like baseball, right, where there are just, there's an encyclopedia worth of individual statistics on every player. And then you couple that with practice metrics, right, and you kind of get down to, hey, with some degree of reliability, and I think that this pitcher will perform this way, right, average pitch speed of, my fastball is 92 miles an hour and that sort of thing. So with that, and then kind of just going back to what you were talking about with like Babe Ruth and stuff, the game has changed phenomenally, right? Since that, there's rules changes and everything. I mean, like you just look up what average pitch speed probably was back then, just like degrees smaller than what it is now. And there's folks that are just doing that all day with the training regimens, the targeted training, right, targeted physiotherapy, and that sort of thing. You add all of those up, and it's one of those things where you're adding this extra piece to it that says I can use analytics and I can use statistics and I can use AI to help make that whole thing better and help improve my players.
That's interesting, right? I mean, I think, Jake, one of the things that we speak to teams specifically around is yes, make players better, but that term again is almost as nebulous as AI, right? Make them better in what? In running, in being in the right position at the right time, throwing, hitting, right? Catching. I mean, there's so many things they could be better at. But one of the things that we hear an awful lot is find better players to begin with, right? So when we are scouting, what are we doing from a technology point that narrows our focus into players that we don't have to shuffle through the chaff to get to the wheat type of thing? From that, Jake, I know you've done a ton of work around the scouting aspect of it. How does artificial intelligence or even data as a whole play into that process?
Yeah, no, I think it's, over the years, and, you talked about Babe Ruth, Hank Aaron, and, that just goes to show so the point I'm trying to make is that we have all of this data that can be used to take existing prospects, whether they're in high school and about to jump into the NBA, or if they're in college and about to jump into the NFL or other sports. We have all of this existing data that goes back 100+ years now that we can use to compare upcoming players or current scouts to previous players. So there are ways to classify different groups of let's say wide receivers in American football. You can classify them into different categories, compare them to their contemporaries that have played in years past, and then make a decision based on what your current team's personnel sort of standing looks like, and make draft picks or free agency decisions that way. And I think that that's the most important thing is, there are definitely, don't get me wrong, there are some certain athletes that transcend any sort of decision making process that you could make, right? There's only one Peyton Manning coming along, just draft Peyton Manning. You're fine. But when it comes to the 5th, 6th, 7th round of the of any draft, right? How do you find Tom Brady? How do you find that player that's going to make a difference based on the certain offensive or defensive philosophy that you have? And so, I see it often, and I'm sure, we all see it when a player is drafted or is signed as a free agent. They may be wildly talented, but they don't really fit what a certain coach or an organization is trying to do. They just don't work out. And then they'll go on to another team and their career will flourish and they'll be just fine. And I think that's the really the biggest thing that we've been able to do with, even as like a low hanging fruit with very simple machine learning models. You can just guess, or not guess. You can have an estimated probability on how good a certain player is going to fit in with your system. And that's really how championships are won, is in that sort of space. Again, there are certain players that you just draft them. You don't need to do any sort of machine learning against. You just know that they're going to be good. But it's all about finding all the necessary chess pieces to win a championship.
So I think it's that concept of trust but verify. Right. I mean, I think
Yes.
that's what it allows to do. And your point again is spot on, man, with that whole, how do I take a player who is good or okay, right? And they get drafted away, or they get reassigned, right? And they just crush it on a new team. They get traded to an environment where they're doing the exact same job, right? Their job is this positional's job and they crush it. What happened? Right? How did we not have that on our team, and how did they have it on an opposing team at that point, right? So I guess one of the questions we get is, does it matter, right? And that's something that we go through on a daily basis, going, if I do this, will I have a better chance of winning a division, winning a game, or even winning a player if I'm going after them, right? Tom, I see you have your hand raised there, mate. Do you want to jump in?
Yeah, I'm loving this conversation. I'm loving what y'all are sharing. I wanted to ask an angel's advocate question. So earlier, y'all were talking about, I think you're still discussing on this point, can technology improve sports? And this bad memory came to mind of the many times I've heard, oh, we've tried that and it didn't work. And I always jump in as, well, how many ways did you try it? And so I'm thinking, when you're aiming to use machine learning, AI, data science to improve sports, how we have the no free lunch theory. Hey, we've got some sample data here. We don't know a priori what model, what algorithm is going to work best on this data set. So we try them all, and we use common metrics to see which one is accurate and generalizes best. When you're going into applying our data science arts to sports, do you go in with multiple approaches? Because I could imagine that the first 2 or 3 approaches out of the gate don't give that great a return, whereas if you had 10 ideas lined up and you try them all, one of those 10 is likely to give some measurable improvement. Am I right here? Or tell me your experience, because I haven't applied our arts to sports.
I think the short answer is yes, right? But I think to get more involved with that is and Param lives, eats, breathes, and sleeps this stuff here, right? It's not only what approach do you take, right? But certain problems may be solved later on once you've pre-solved another problem, which may lend itself to then falling into another one. So Param, I'm going to let you talk a little bit more zeros and ones on that one from an approach perspective, if you want, mate.
Yeah, from an approach perspective, you do have to try multiple things. And I think a lot of it too is reframing the problem in different ways and creating multiple hypotheses, right? So just kind of getting back to just core data science, right, or statistics, right? You're going to have to try different ways of looking at the problem. And like, the models are the models, right? There's 18 million different technology ways to approach, hey, let's go try different models, right? There's automated ways, there's manual ways, you can baseline, you can try working in team, that sort of thing, right? That part of it's solved. What I've been noticing, and what's kind of, I think, not unique to sports, but it's very much characteristic to sports, is that the feature engineering work is so much more fundamental than the actual data science work, right? Getting that right it just pays enormous dividends, more than anything else, like more than financial data, right? More than NLP corpuses and that sort of thing. With sports, because you're so dependent on, especially if you're looking at things like raw telemetry, is making sure that you're confident in those, that markings are correct, that your Cartesian plane's accurate, and then the features that you're extracting them make sense for the problem that you're trying to solve, right? And that is honestly where, and I call it the unglamorous part of data science, right? Is grinding out those features. But once you do, then you're able to reap the rewards. But like, yeah, being able to pull out things like the bearing of the ball, the angle, the trajectory, projected flight path, then leads you to things like catcher out probabilities and that sort of stuff.
And Param, as you know, our terminology is still in flux because the data age is still kind of new. When you say feature engineering, are you kind of throwing in feature conditioning, feature reduction, and adding additional features that are engineered? Or are you talking specifically engineering new features from the existing feature set?
It's an umbrella term, right, for the things like the cleansing, for dropping, non-performant features or features that are not necessary for some things, and creating new ones. I think with sports, the cleaning, being able to work with them in a usable way, because a lot of times those feeds are coming in compressed, right? And then being able to surface new features out of it, like I mentioned, right? Those are all kind of under that same umbrella. But it used to be like 80% of the work. With sports, it's probably more like 90% of getting to a model.
Understood. Just to be safe, I've been starting when I'm training people to distinguish between feature cleansing and feature scaling, feature encoding, just to give a little more granularity to all those processes we do. But I appreciate what you meant by feature engineering. And I wanted to ask, when you're actually doing the part where you're creating new features, which is what I specifically call feature engineering, do you find that domain expertise helps you kind of know what you need to engineer, or are you doing the throw a bunch of polynomial expansions at it and reducing down to the ones that are the most powerful?
Domain knowledge helps. I think just being aware of the sport and paying attention to what's going on in that particular like tranche of, this is what this industry looks like now, also helps, right? Like, you don't have to be someone who's like, I'm not a sabermetrician, right? But I do enjoy baseball, right? And, there's enough gleaned out of that game to help with things like surfacing things like rotation of the ball and that sort of thing. Hey, this is something we need to pay attention to, right? Or like the trajectory of the ball, for example, or the angle off the bat and that sort of thing. All of those things, just understanding the game is enough to get you started if you've got a reasonable enough background in, statistics or data science to help go develop something.
Yeah, that's something we see, right?
Right.
So I think, Tom, to your point, it's something that we see with the teams and the clubs that we help. A lot of what they bring to the table is that domain expertise, right? And a lot of what they want to do is fix a certain area or get better in a certain subset of areas to make something better. So I think to coin the umbrella term there is AI in a sports club is really much a combination of the domain expertise and the technology expertise coming together, right? So I think just sort of letting the fox among the hen house without any contextual awareness of what they're trying to do, what results in a fantastic result, right? You're not going to get something that's amazing. But if you go in there and you have the right contextual awareness, you have the right partnership with the team and the technology provider, I think you can do some really good stuff. And I think together short circuits a lot of the learning aspect of it from a what we're trying to achieve and why we're trying to achieve it perspective.
Two other angel's advocate questions, and specifically targeted at Param first, but then whatever John and Jake want to say. Do you find that the choice of an approach is well informed by doing good statistical analysis in your EDA or doing good basic data storytelling in your EDA before you go to machine learning or deep learning? What's been your experience there? I'm very curious.
Yeah, and Jake has good insights on this as well. Something we worked on not too long ago, right? Where it was, it's a little bit different, right? But the EDA and the storytelling. So the storytelling for me comes from the problem formulation, right? So where we're working with our partners, right, in this, right, who are some of these teams. The EDA part of it is understanding at a high level what the distribution of the data looks like, what's the shape of the data, do I have any outliers, that sort of thing. And you do that, but it's different because you're almost looking at it as a spatial analytics problem. So if, for example, you see someone running up the field in your telemetry over a time period, and then you see a big jump where, in a split of a second, they're across the other side, obviously something's wrong with that. The way you use it and the way you transform it, I think, is different than, say, like a tabular data set that you use for something in financial services or a classification problem or something like that. With sports, it's definitely a thing that you have to do. I think that it's just a little bit different than what I've done normally in other broader data science pieces. But Jake, I'd like to, since you helped out a lot with that, I'll let you weigh in on this one as well.
I don't know if I have enough data science kind of experience to know what is an EDA. I don't know what that is.
My apologies for using an acronym. Exploratory data analysis. And
Okay.
then one thing I also encourage, Jake, is when people are on their way to developing a machine learning model or a deep learning model, there is so much value to give to the organization through what we learn in getting the data ready for machine learning. So I'm specifically asking too, some of the stories you can tell from the data before you get to the predictions.
Yeah, I'm just gonna kick it back over to Param. I don't really have, yeah.
Yeah, Jake, I think this was a lot of the work we were doing where we were looking at the raw telemetry and we're trying to understand if it looks sort of canonical or normal with what we would expect in like a given thing. So that to me is why it was different than kind of traditional EDA where, hey, let me do a plot. Let's see how the data is distributed. Do I have skew or is there kurtosis, that sort of thing in this. With sports, it's not like that. You're not going to see a normal curve on some things just because of the nature of, say I'm profiling, I don't know, like completed touchdown distances, right? And you're going to see big spikes and outliers, right, with your Peyton Mannings and your Tom Brady's and that sort of thing, and then everybody else, right? So for it to not be normal is completely normal, right? And when I say normal, I mean kind of bell-shaped. So with things like the telemetry, you can't really do that, right? Because you're looking at a multidimensional thing, right? And you're exploding it out differently. And what you're really looking is to see if across that time stream is if it's performing as you're expecting. So yes, you do EDA, but for sports, I think it's a little bit different. Or I think also more generically in terms of spatial analytics, it's a lot different. If you're looking at aggregated metrics like pass completions and that sort of thing, then absolutely, it's kind of a standard EDA path that you would use.
I think what's interesting, and I'm getting questions here as well, is that one of the things that we find a lot that Jake and I do on a daily basis, right, is look at the overall technology footprint that a team would have. And a lot of them aren't this glorious modern estate where you can go and you can find all the data that you want in a single place, and it's clean and it's in a format that you can readily use in whatever machine learning or data science tooling way that you want. A lot of the work that the teams are doing is somewhat catch up, right, to more of the state of having a cloud footprint, right? Moving away from on-prem and putting stuff into the cloud. And once they've done that, how do they remove the data silos, and how do they put in a data warehouse or a data lake architecture in which they can now start aggregating decisions across different data sets versus one? So I think a lot of that leads up to the natural conversation of, okay, cool, my data's here, now what, right? So look, as we come up on time here, I wanna pose one final question. Jake, I'll start with you and then go to Param, right? It's not an easy question, so probably glad I left you 3 minutes to answer it. But someone comes to you and says, Jake, I'm from XYZ hockey team. I want to do some AI. How do I start?
Yeah, I think it's all about building a good foundation of data first, right? You can't start building out a decision-making process without having any data to make that decision. So really, I think it's important to assess where you are as far as how your capabilities on gathering data, build out new feature sets, as Brown talked about, and then get going with machine learning. But I think the upfront effort that goes into gathering data, storing it in a way that's easy to manipulate, it can't be overstated. I think it's a step that a lot of groups like to skip or either speed up. I really think it should be one of the more important pieces, because it's vital to have all of the necessary information to make decisions.
Absolutely. Well said, right? I mean, a lot of the answers that we have to say right off the bat to those questions are, well, you can't, right? Because you don't have your estate in a way to do that. So let's play pretend for the last minute here, Param, and say, okay, I have my data estate in such a fashion that I have my data sources integrated into a single accessible layer. I want to do AI. How do I do that?
Let's start with coming up with a specific problem that you want to solve with it, right? So let's target, I think we were talking about the same topics earlier, right? Like what's an off the field metric that you want to improve on? Is there a specific target area, right? And that sort of thing. And then develop the statement, come up with a hypothesis, and then see if the data can help support it.
That's awesome. I think that is sage advice, right? I mean, at the end of the day, if you're not doing something that is either going to help achieve a business outcome or help drive efficiencies, or that's being driven to better something, you're on a science project, right? And the problem, science project, those two words are probably the worst words to put together in an artificial intelligence or a data science machine learning realm, because you go through something that has an expense of time and effort, and there's no real impact with the output that you've got. The output could be brilliant, but it doesn't impact anything from a business or a player or an outcome perspective. You've lost sort of credibility, right? So I think we're very early in our journey as far as artificial intelligence is within the sports realm. There is a fever pitch, excuse the pun, right, of want and desire to do this kind of stuff. So Jean, thank you very much for having us on your broadcast here. And Tom, thank you for being a guest and throwing some questions at us. We appreciate that. Thank you. Sorry for the troubles you had earlier on. But this has been great, right? And if you guys, look us up on LinkedIn, you can reach out to us and we can continue the conversations here. I know we had some people coming in and out, but thank you very much, John. This has been amazing.
It was an honor to have you. And by the way, that was outstanding. Thank you to all of you, and thank you to all attendees. And if the attendees have any questions, are you okay to take a couple questions from the attendees?
Sure. If anyone's got a question,
Okay,
I'll be happy to field a couple of those real quick. Sure.
Let me quickly give them access to unmute themselves.
I think Terry, you've got your hand up there. Are you able to unmute?
Yep, you
Put
can.
it in the chat.
Okay, can you hear me?
Loud and clear.
Okay, just a couple of questions. The sports side is something new I've started looking at just recently on data science and trying to decipher. Okay, so what kind of attributes are best when evaluating, and whether it's you're trying to build a team, the profile of a potential player, what it's going to take to improve the team. So I was kind of looking at some attributes and looking at the whole person player, their mental side of it, their attitude, how well they perform academically and things like that. And then their physical attribute, how strong they are, how well they do and how positive and aggressive they are in their physical development and their aerobic development. Medical problems, do they have any medical problems that are plaguing them? Is that an attribute that can contribute to it? And then looking at position execution and looking at the individual positions that a player may play and what are those attributes that would be important that could be measured to determine the future success in that position. And then, of course, as a whole person, holistic approach to it, what's their off-field performance or behavior, how active are they in the community, and thinking more in terms of professional athletes, because they have a very strong impact on younger kids. And if a professional team is looking to attract the best cohesive quality player to make up their team, are those things that can be measured to help maybe assign a probability score, if that player is going to increase their probability of being successful in the field as well as off the field and being positive in the eyes of their customers or fans, if you will. And have any of you gone that far into your analysis of the data science for the sports area?
Yeah, so I think a lot of that goes back to, because it's more than just the numbers, right? And Terry hit the nail on the head. It's when it comes to making a decision, whether it's college recruiting, whether it's scouting in the professional leagues, it's more than just their performance on the field, and as well as just kind of their athletic measurements. You talked about previous injuries and how does that play a role into things. Now that is definitely something that we can kind of chalk up to, or as far as their probability of how well they perform over a certain amount of time, given historical analysis, with different types of injuries. Now, of course, the medical community is constantly, improving the way that athletes get better at. I mean, 20 years ago, you couldn't imagine coming back from an ACL injury. Yet, 10 years ago, Adrian Peterson, the year after his ACL, is running for 2,000 yards, right? So things like that are changing, and so we can use data in that sort of aspect. Now, when it comes to like the psychology, there's a really good book out there called the Game of Tennis, or the Mental Game of Tennis. And it's all around the psychology that goes into being a clutch performer and being a role model as well. They usually go kind of side by side. Now, that is one of those, it's an additional feature that that I believe that decision makers such as coaches, general managers, scouts, it's yet another piece that they can use to augment their decision making. So it's lumped right there next to sabermetrics and that sort of stuff. So I think it's just yet another factor that that's taken into consideration. I just, for us, the data that's there, that's used to say, all right, well, this player is, they check the boxes mentally. They come across as a great role model. They're going to do great things from a fan perspective, but can they also play? And if they can play, are they going to be able to sustain it for a long time given their injury history? So, it's just another one of those factors that's used in making decisions.
Yeah, you're spot on. And I think, Terry, it's a great question, right? Because everything that you described, all the facets, there are data sources, right? The more data sources that you have, the more rounded your decision could be, right? Based upon the output there. But then you have going back to what we spoke about earlier, the unpredictable human nature, right? That's the variable that you can't really take into account. I mean, you've got great players who make a great team, who make a great impact, and then they do something so disastrous off the field that they're gone. So that changes the entire, look at Trevor Bauer, for example, from the LA Dodgers, right? Well, they changed the entire makeup of the team because of this off-field behavior precluded him from being on the team, right? And that changed the entire output for everyone from a coaching perspective and the condition and players there. So everything is interconnected, and data science and artificial intelligence and all the wonderful work that's done within sports isn't a one and done, right? It is a continuously self-fulfilling prophecy, right? Once you've got an answer, you get another one because the answer data sets change, et cetera, right? So it isn't just a one-time thing.
Yeah, I kind of look at it like, I come from the Lean Six Sigma world as well. Everything's continuously changing, continuously improving, you hope. But I would think that would be the same for any data science model. It will continually evolve.
Yep, awesome. Thanks for the question, though.
Thank you.
That was awesome. Thanks for listening today.
Thank you.
Do we have any more? Cool. Well, I think, again, John, thank you so much for giving us the opportunity to come out here and chat about the stuff that we love.